This is a production of Cornell University.
I actually thought this was really cool from a sort of, I see people investing a lot of money in dealing with algae and weed management, vegetation management, which sort of starts with algal developments in many ways, right? Shading things out and lots causing other issues. So the use of barley straw is pretty common now. I know this was pioneered, many years ago. Rock Swad did this work in his younger years. In Nebraska, it looks like when the water temperature gets to about 55 degrees, you put this barley straw right at the inlet. There are chemicals that are eluted from the straw. I honestly haven't looked at the science of this at all, but I do know it is pretty widely used. And, when you consider what's involved in putting one of those, for lack of a better term, wedding venue fountains in the middle of a golf course, more guys are going to the bubblers that are a little better. I know there's lots of solutions, but this is a pretty simple one that even gets used at a swanky place like Jim's got there at Fairview. Carl, always thinking about fun things around golf courses and really love this sign. I got to play a couple of weeks ago, and I got to tell you, when you play in a scramble and you're a lousy golfer, it gives you all these feelings because you don't have to sweat your crappy shots. In fact, as soon as you hit a crappy shot, you're happy to support the other crappy golfer you're playing with who might, on the off chance, hit a good shot. And I think when you approach a round of golf like that, I think it tends to be just a little bit more fun. And I think we've talked about in previous episodes the fun coming out of golf. But I just had this real thing about dogs and wet dogs and dogs that are out in the rain, right? So, people want to know why their cars smell like wet, sappy dogs. I'm sure you know what this is, Carl. And also Tim Gravert out in Iowa, everybody's in for rain and I want to go out. And I give you that look like, what are we doing here? Get me out of this place. And dogs have a way of communicating those feelings just by their looks. So, Carl, you had something to say about something I mentioned last week on the show. I actually thought is pretty cool. So why don't you take us through this urban nutrient management stuff we worked on?
Yeah, so wanted to talk a little bit about the backstory of how this document came to be and sort of continue on from some of our thoughts last week, which is about, we talked about fertilization, soil test, MLSN, and then we mentioned this urban nutrient management plan, which sort of codifies some best practices around how we use that fertilizer. And really what it comes back to is not so much turf grass quality, but water quality. And that a lot of these documents and best management practices are connected to reducing the amount of nutrients and sediment that's getting into the water and causing issues. So one of the guests this week we were trying to get was Mike Goatley, and I read one of his papers he was involved in, which talks about the history of turfgrass nutrient management as it pertains to the Chesapeake Bay watershed and how the regulatory environment has shaped sort of how we use turfgrass fertilizers in this watershed. And this comes back to water quality, right? So the picture that people can see on the screen from this watershed, which is really big, stretches across 6 states. You can see a lot of red on that image. Red means there's not a lot of oxygen in the water. That's because these nutrients are basically powering organisms that are sucking up all the oxygen, and there's nothing left for the plants and animal life that are needed to thrive in those situations. So we know that nutrients are a concern here. How do we fix this, right? What can we do? The sort of standard approach from an environmental engineering perspective is develop a TMDL. Some folks may have heard this before. It stands for total maximum daily load, and it's essentially a process that you go through to clean up water. So first, okay, you identify a problem, and then you got to figure out, okay, how many pollutants are getting into this water body? How do we quantify the amount of nitrogen or phosphorus or sediment that's getting in there? And we need to do a lot of assuming, and we need to run this through a bunch of models, right? There's a lot of land in this watershed. There's a lot of equations that go into that, but they try and make their best estimate. Then they got to figure out, okay, how much do we have to reduce that pollutant load so that we get clean water? So they develop those targets. That's the TMDL, sort of targets, actual numbers we have to hit. And then we got to figure out ways to hit those best management practices. So that's where these sort of plans come in. Hopefully you do that and eventually the water gets clean. So the numbers for Chesapeake Bay watershed are this. 84.3 million kilograms of nitrogen. We don't want any more than that per year. 5.7 million kilograms of phosphorus, and 2.9 billion kilograms of sediment. So we don't want to exceed those levels. And then we got to hit those targets by 2025. So those are like really big numbers. Again, sort of abstract, like where do we get those? And that comes back to this modeling component where there's a lot of assumptions, right? We've got ag contributing, we've got turfgrass, right? That's what we're going to talk about. There's natural sort of secretion of nutrients that just sort of get out of the water. And one of the assumptions we learned a couple of years ago in a call, Frank, with some folks in the New York State DEC was that they assume every piece of turfgrass in this watershed is fertilized. And we were sort of like, oh boy, that's a red flag, right? That's probably not a good assumption. And it was too late for us to sort of change that assumption in the model, but we did sort of look up some numbers and, how much do homeowners fertilize? Maybe that's a good proxy. Seems like 40 to 60%. There's not great data on that. It probably is regional. It's probably breaking down by rural, suburban, urban. There's probably different amounts fertilizer going on there. But the bottom line is that assumption of 100% is wrong, right? That's not good. But there's a famous quote from a British statistician, George Box, and it says, all models are wrong, but some are useful, right? So for us in turfgrass, we get really defensive and part of those assumptions being 100% of turf is fertilized lead to, hey, we got to do a lot of these best practices to reduce our fertilizer. And a lot of times there's a regulatory aspect to that. We have phosphorus laws across all these states. There's nitrogen sort of caps in some states. But I think what it's accomplished is probably still pretty useful. And part of the accomplishment is codifying these best management practices. Right. There was an expert turf panel in the Chesapeake Bay, and they came up with these 10 core practices that if we do these things, we can, estimate that we reduce nitrogen leaking out of turf systems, phosphorus leaking out. And the first one is how we came into developing this urban nutrient management plan. And it says basically develop an urban nutrient management plan for the property based on a soil test. And that's why we talk about MLSN last week. We talk about, we should probably use less fertilizer. Having that plan, codifying that helps reduce the excess fertilizer. Now, two of the other ones I think are really important, have nothing to do with fertilizer, but they sort of have everything to do with what turf does in sort of our landscapes and how it pertains to water quality. The second one is maintain a dense vegetation cover of turfgrass that reduces erosion. It reduces runoff and retains nutrients. So that is saying, there's a reason we have a lot of grass. And it's because it slows the water down, right? Let's slow that water down, reduce erosion. And the turfgrass is good at using nutrients. Let's let all the nutrients that are in that water seep into the grass and the grass can use them and it takes it out of the water. The other thing that they mentioned, one of the BMPs, is make sure that your soil in turfgrass systems has good porosity and infiltration, right? So that's sort of a reason if you have compacted areas, especially where water's sort of on a steep slope, it's going really fast. Again, we want that water to go in and not across. And again, that reduces our pollutant loads into the Chesapeake Bay. And these are good things. This is why we have grass and why we have a lot of grass is because it functions in these environments. So part of the BMPs is like, make sure you have all grass and not bare area. Yeah. So that's a good thing from a turf management perspective.
Yeah. So Carl, listen, and let's go through a couple of things, right? Because each one of these things has its own story to it. Let's start out with soil testing, right? We've actually been, as you mentioned last week, not necessarily supportive of soil testing if it's interpreted in a way we think is not consistent. In fact, we even made the Asian turfgrass programs shout out this week from Micah Woods, commenting on our conversation from last week that you led, right? So it isn't that you're soil testing, right? That's not really the issue. It's the way you're interpreting the numbers that you're getting and the way you're calibrating those soil nutrients to your observations and your turf performance in a measurable way. Could be growth, could be disease resistance, it could be traffic tolerance, whatever that is. Okay. So that's the first thing. The second thing I want to say is I remember driving by the golf course with this environmental engineer was visiting us one time, and we just driving like we always do from the campus, which is very urban, out to the turf plots and where the golf course is, and which is very suburban, on the edge of suburban and rural. And the first thing the engineer says, "Man, it's so great. This is like a sponge for all this water." I don't know. He actually says, "I don't know why anybody gives golf courses a hard time. They're like perfect for the stormwater management needs." So some of it is, Carl, we don't always look at things the way other people look at them. And that's what you just demonstrated in your point there. The engineers, well, it's grass. It must be fertilized in some ways. Now we do know, back to this point, when you got a lot of organic matter and you got active soil life, you are releasing nutrients, right? But theoretically, one would hope that wouldn't exceed what a plant and a system could take up in a rhizosphere. But there are times when just organic matter levels build up and can leak, and there could be just natural releases of nitrogen. Now, the last point here, I actually got a picture to talk about things we don't think about, where I'm going to talk about sports fields a little bit today, Carl. The intersection of these ecosystem services and the functional use of this landscape is very dramatic on these sports fields. And I'll just ask you again to remind me, you read a paper or talk to us about a paper that showed compacted sports fields are getting on the radar of stormwater management engineers, to your Chesapeake Bay point. Now, this isn't a chemical property, Carl. We're talking about soil physical properties, which is what your last core management thing was there. Can you talk a little bit about, what we mean when we say compacted surface? Obviously, there's no grass here, so that's not good. But also the compacted soils on these fields create runoff problems as well.
Yeah. So, we talked a little bit about the modeling that goes into figuring out, okay, what pollutant loads getting into the water. There was a thesis out of Temple, and they do a lot of monitoring of, okay, when we have a rain event, how much water comes off of this land and this watershed, and how fast does it come off? And you can do some calculations based on the land use. So if you have a sports field, that's sort of a natural, lawn, turfgrass environment, that's different from a developed housing area that has a lot of impermeable surface. It's different from a forest, and they have some estimates on how much water should come off. So they do those estimates, and then they're collecting data on how much water is actually coming off. And they're like, there's more water coming off than we thought, and it's coming off faster than we thought. And, why is it? What assumptions are we getting wrong? And what they're sort of pointing to is like, there's all these athletic fields, and we're assuming an infiltration rate of X, and it's coming off faster than that. And so what they're figuring out is that if these athletic fields are compacted, that water's not going in like it's supposed to be, and it's overloading. There's more water than they are expecting coming off of this watershed, and that affects how they design green infrastructure or water control structures at the outlet point. So they were sort of pointing to like that's maybe something we have to consider, either changing in our model, or it would be great if we manage these sports fields to have a certain amount of infiltration and collect that water like we think it should.
Yeah. All right. Well, since we're talking about the soil, let's start with soil temperature, which was surprisingly warm in the New York metropolitan area, well into the 60s almost everywhere, except the highest elevations are pushing into the upper 50s. But you've got temperatures well into the 70s in the metropolitan New York area. And this is a pretty big deal, because you're now in the throes of active growth, active soil life. You want to make sure you've got your summer patch sprays down, your soil pathogen sprays, because obviously the infection period for these organisms is well underway. It's been warmer, right? The early part of last week, before it got cool, most recently it was in the 40s today here in upstate New York. But I can tell you, warm overall last week, a little more well above normal last week. And the interesting thing is, and this is, I think, and also a very interesting point of discussion, Carl, because this was just like the second week where I've observed some drying in my eye tests of traveling around the area, right? And when you look at precipitation minus evapotranspiration, you see again the sort of localized nature of precipitation. And again, when we're talking about runoff, we got pockets of 3 and 4 inches of rain being dumped in some of these areas in Scranton, along the Cape, on the north end, North Shore of Long Island, into the Hudson Valley. And then not 10 miles, 20 miles away, you're at an inch or 2 inch deficit, right? And so it looks like the drying is going to continue. Now, looking at the lawn water model, Carl, the model is picking up the drying that's occurring. It picked up the rain that went through. This is for Long Island. This is for the Farmingdale location. So sandy areas now still have plenty of water, don't need to irrigate. We're definitely, I think, honing in on the drying. The growth estimates are also showing that growth is pretty active, particularly when you're not irrigating. So in some of these locations, you better check these things because these localized models are going to indicate whether growth is going to be higher or below normal. But this is where it gets funny to me, Carl. We talked about this earlier. The foliar models have been very active much earlier. I think even Art mentioned this morning, the brown patch model was flaring up. Soils are drying, but the foliage is wet, right? And you look at sort of where we are today and where we're going to be by the end of the week. Would you spray, Carl? Where would you, if you're at the end of a spray, would you spray or would you hold? Tell me where what you're thinking. You got dry soils, you've got to maybe add some water. Talk to me a little bit about management decisions with your water model, your growth model, and your disease models all integrated together. They're all wrong, right?
Yep.
They're all wrong, right? But they're all useful.
Yeah, I think the one thing with the dollar spot models, and we talked about this a bit last week, is it spiked up. And it should be coming down now. So if you were to run the prediction on that to like June 2nd or something, I think more of the region's going to be in green. We're going to have these cool nights, right? So from that perspective, I think I would hold off again. And this is the perspective of like, I'm a course that has, let's say I've accounted for 5 fungicide sprays on my fairways for the year. And I probably had to go out 2 weeks ago when it sort of spiked up there and it got really hot and humid. So I've got 4 left, and I've got June, July, August, and we know the fall pressure has been getting
That's what I'm
worse,
talking about.
right? So I would say
saving, right? We've been saving these applications in the spring because the whole thing shifted to the fall.
Yep. So I would save, and the nice part is that growth potential is going up. We're getting into sort of ideal temperatures. If you have the ability to irrigate, right, and you have soil moisture and it's not limiting growth, even if I got a little bit, I would expect the turf to grow out of it. So if I'm thinking large areas, fairways, and I've got limited sprays, I'm definitely holding off. And I'm even looking at the Smith Kearns model, and it's interesting. It's very low the next couple days because it doesn't look at the leaf wetness. Like we rely on leaf wetness, which considers, did it rain a little bit? Is there a lot of relative humidity? The Smith Kearns is only relative humidity. So if I look at both of those models and I sort of centralize the recommendations, I'd say, yeah, I would definitely hold off on fairways if I had a limited amount.
Yeah. Okay. Now listen, my phone's been ringing off the hook about natural and synthetic turf. And one of the things that keeps coming up is there's not transparency between the governance and stewardship of sports fields, Carl. And we're going to be talking about this a lot over the next few years. We just got a grant to do some work in this area in school grounds. And I want to use the example of some of the things we've learned here at Cornell as a way of helping people in the grounds area, the sports turf area especially, and maybe golf guys will have something to learn here as well as how to operationalize or add some data to their technical operation. This is a story that started with me serving on a governance board for our athletic department. I've been the chair. I just finished up my 17th year as the chair of the faculty advisory committee, and I am now retired from this committee. It has been a long and storied journey that included the renovation of the swim test here at Cornell, which fell under the auspices of this. One of the things I was responsible for doing every few years was to give a presentation to the faculty. And one of the things the faculty senate was very interested in, listen, the Cornell Faculty Senate is the largest collection of nerds in the world. It's somewhere between a nerd fest and the Roman Senate, where we love to hear ourselves pontificate. So every once in a while, they invite a knucklehead like me to come in, and I always get a lot of questions about concussion. So I come prepared to discuss our concussion management program. Let's face it, you're at a university, your brain is the most active muscle in your body by far at this place than any other muscle. But our athletes have to be very mindful of concussions, right? And this is something that the NCAA has been all over. Obviously, this is something that sports in general has to pay attention to. And we have a collection of data that over the years I've been presenting, looking at the various sports. This is from 2013 through 2018. You can see football in general is very high. Men's ice hockey in some years could have as much as football. Women's ice hockey still gets a fair amount. Lacrosse, another sport we're fairly good at, can be above average many years. And even wrestling, another sport we're pretty darn good at, trying to get all those well-fed Western Pennsylvania boys here wrestling around. So obviously this is a significant concern for governance, right, Carl? When we talk about governance versus stewardship. And of course, the governance includes playing the game different. Maybe you're not going to have kickoffs in high school anymore. These things that happen at the high levels maybe impact us at a lower level. But I can tell you the game changed for us here at Cornell when we hired the assistant coach for the national champion Stanford soccer team a number of years ago, Coach Smith here. He gets here, he gets hired, he walks out on the natural grass field for the first time, and he says, "We can't play soccer here. I can't kick a ball in a straight line." And that led to investments of a fair amount of money to get the fields up to shape. And what it did also is it thrust myself and Carl, and at the time, my graduate student, Chris Sitko, who's now the director of this whole operation, thrust us into having to manage this, work with the coaches, work with the people that were managing these fields, work with the players, work with the maintenance staff. And they were all a bunch of disparate groups that there was no centralized focus for the way this field was tended to. Now, the first thing that jumped out at me, and Carl, you probably heard me say this, is there's two kinds of coaches. When you're thinking about just governance from a coach's perspective, you got two kinds of coaches. You got a coach who can say, "I want the ball to do this. Here's a good picture of a athlete deflecting the ball to the side and then maybe advancing it." And there's that little bit of friction that occurs there that some coaches will say, "Really, I want it to behave this way," right? Good. All right. Then we go figure out how to do it. Then you got these coaches, "Oh, you need to mow lower. You need to roll more. Why don't you core this field?" Wait a minute. Stay in your lane, buddy. You're the coach. We're the grounds people. I had to realize, whoa, now I know why I'm an academic and why I have so much respect for guys like Ben Palmer and all, Nicole Sherry, Dan Cunningham, all these guys that are managing fields on a regular basis, dealing with coaches. So we became, as you might expect, and Carl, very data driven. Like if the coach is going to tell us what he wants, we're going to have to use numbers in one way, shape, or form to know how to make adjustments in our maintenance program that then results in measurable differences in these devices, be they for hardness, moisture, traction, ball roll, ball bounce. So we have two setups for our soccer fields. Our Berman field was built in 1995. It's a beautiful sandy engineered sand with compost and soil in it. It's about 2 acres. It was resodded to Kentucky bluegrass in 2016 and is now being renovated into a ryegrass surface because the other operation that the students practice on is an off-campus location where they've got 2 practice fields, both for men and for women, and some training ground in between that are primarily ryegrass annual bluegrass surfaces. So one of the things that we've been able to do is to use this data to make these 2 different playing surfaces play the same. But the annual bluegrass problem has become so severe on the Berman field that we've not been able to combat it. So we're going to be shifting more of it over to ryegrass. So one of the things I want to say about this in general is I believe cool season natural grass fields are done best when there's a bluegrass base that provides you that stability for a cleat to dig in, and then whatever the hell you want to grow on top of it. If you want to intensely seed ryegrass, if you want to put more tall fescue on it, I don't really care. I worry a little bit more with tall fescue that it can get bunch type. But as you heard from Cal Bigelow a couple of weeks ago, we can actually do tall fescue pretty low. Well, when we started this operation with them, it wasn't looking good. We were having all kinds of problems with irrigation. We started top dressing. We needed to raise the sprinkler heads. We had a lot of infrastructural things. So the first thing I'm going to tell anybody, if they're talking to me about natural versus synthetic, is, do you know what you're doing? Do you have an infrastructure that can actually support the goals that you're trying to achieve? And so what we did, and Carl, I believe you and Chris led this effort years ago, is we basically said, okay, the people we're talking to only understand numbers.
Yes.
They don't understand anything about biology. They probably weren't that interested in engineering, but they might be interested. They're very much interested in the numbers. So you guys did a great job of saying, okay, how much do we do this, for that, the other thing? We started to look at the various fields and the amount of time we were spending on them with floating time. And this is where we learned the concept of wrench time, right, Carl? How much time people spend actually doing the job. So we give them reports on, hey, here's what we did. So if you're in a school district, if you're at a municipality, just track your hours. What does it take you to do these things? And then start beginning to communicate these things in a way that say, here's what this takes. Here's the overseeding that we had to do. Here's the week-long practices where we dominated by mowing. Maybe we did another 13-week period where we did more top dressing out there, right? Again, just putting in the hours over a 13-week period. We started to talk to them and give them reports about the data that we were finding and the things that mattered. We started to get them to use covers in the high traffic areas where they'd see results. So we had been able to create an environment over the last, well, essentially 7 years, till then we hired Chris Sitko back to run the whole operation, where we, had to methodically work through the governance and different parties involved here. And then even when you do that, Carl, the senior day comes along and you're calling me on a Saturday. It's like, Frank, they got senior day. They're calling me that they don't know what to do. We didn't have a real plan in place, right, for what to do. We didn't have a person really that oversaw it. So they were calling us and we said, I don't know, get out there and test it. We tested it and said, don't play on that field. The darn thing is frozen. Even when you take the snow off, they took the snow off and played anyway. So even when you give them the data, sometimes they're going to do what they're going to do. Here's where I'd wrap this up, Carl. I think any operation that manages sports fields, golf courses, or grounds should have established protocols for the way they go about their business, right? It shouldn't be centered in just what a superintendent knows or a foreman knows or the people who work there for 15 years knows. There should be things written down to say, this is how we operate this place. And then we have to use that as a way of communicating our needs externally, right? We keep following up with people. We hire good people and you treat them right. I mean, that's pretty much what it comes down to. When we talk to people about natural versus synthetic, right? We know that there are competing priorities, right? They're competing priorities for use, how safe it is, the environmental costs, the money, and the sociology, which is there are egos associated with getting certain kinds of surfaces in communities. There's the way you fund these things. Is it a capital expense or is it an ongoing expense, right? A capital expense like a synthetic field, you don't have to worry about maintaining it, so to speak, and versus a natural grass field, which is going to have ongoing expenses, which includes maintenance differences that you can learn more about at our sports field website. Here's the QR code for that, and you can go to our Safe Sports Field website and get some information. And this will be renovated as part of our granting program, and also the best management practices that are available from a variety of states. I know the New England guys did a really wonderful job with this. And so, Carl, that seems to be it for me. It'll just be me and you. Are there any questions that came up or comments you want to make?
So we don't have any questions, but I think the comment, Frank, is when you're trying to affect change at that governance structure and tell them, hey, we need X amount of people for X number of labor hours. We need this equipment. I remember we talked about mowers and replacing mower blades, and it took you, right, professor in the College of Ag and Life Science. It took a graduate student at the time, Chris, and then me. So three people. I didn't know. I'm not sure I entirely knew what I was doing, but two people who knew what they were doing, and me who was trying to put all the Excel stuff together to really communicate those needs over several years to start to see that change. And then finally now Chris taking over and having that sort of baseline, being able to continuously communicate those. Now we're going to have an undergrad student who's going to go out and take this playability, a couple times a week to again sort of, figure out when Coach Smith says, "Hey, I don't like how the divoting it is," or "I don't like how the ball's reacting." We can have numbers that say, "Oh, that's when we see the shear test look like this, or the firmness test look like this." It's tough for one person to affect all that change. So in the past, I've said, you got to hire somebody and they need to know what they're doing. But that person also needs support in communicating those numbers and collecting some data. So it's just not as simple as a K through 12 district hiring a person who knows what they're doing. They need to empower them to have other people and train other people around them and be able to communicate and work with the governance structure to say, listen, we can't meet your expectations with this. I need other people to support me. And that's how we're going to ultimately.
And just to review, Carl, in 30 minutes, we did urban nutrient management and soil management, right? Then we did dollar spot and digital tool modeling and how to use those models to make decisions. And then we talked about managing sports fields in an operational way to get sort of be able to sort of know what you're doing and then communicate it to other people around the various surfaces that we manage. I can't imagine you're going to get more in 30 minutes anywhere else, Carl.
No. And one quick question Vitas was asking about the data from shear and compaction tools. Is that sort of a good way to get a holistic sort of look at the performance? I think so, right? I mean, I think firmness is sort of number one I would go to, and then that traction component is the next one I'd go to. Any comments from you, Frank, on additional tools, or if those are sort of what you would start with?
I think the ones we use there are pretty good, but I think you have to realize this. They're all indirect measurements of things.
Yeah.
Right? They're not direct measurements of things. That's why it is important to calibrate them, whatever device you're using. The reason I think we use them is there's already a data set that a lot of different sporting organizations have provided feedback on. And I know FIFA's really, elucidated these things to no end. So there really isn't any end to it. But I'd say those are two good places to start because number one, you don't want these kids cracking their heads open when they hit their head on the ground. So if they crack their heads open banging into each other, that's a different animal. But it's not something that you definitely want them doing. And traction is something it's good to know if the turf's going to slip out from them, which is bad, and also that the turf is too stiff for them, which is also bad. So there's that sweet spot in there. I'd say those are the two best ones. If I added anything, I would probably add the ball roll and the ball bounce, because that also tends to be something that the players and coaches can really associate their performance with.
Yeah. So that'll wrap it up for us today. Yeah, a lot of ground covered today.
A lot of ground, Carl.
Ground cover turf.
We covered the pitch, as the Europeans would say. We fully covered the pitch.
Covered the pitch. So thank you all for those attending live. You guys will see us next week with Ben McGraw. Take care.
This has been a production of Cornell University. On the web at cornell.edu.